Hello, hello, hello. Okay. Hello there. Eric, how's it going? Ardelia, how are them? Is that a hummus you have there? No, I'm not. It's fine. It's fine. So hummus is a good, you know, I don't know, thing, I guess. So, breakout.md. All right. How's it going, gang? We're still missing Sebastian and Sylvia. I think we have. Appreciate it, Jeremy. Yeah. Matt, good to see you. Okay. Not losing that one. Right. Today. Reading code and scopes in JS. In this breakout, we'll practice reading and evaluating pre-written code in our heads. Developers don't read code top to bottom and instead, in some ways, try to mimic the computer. Remember scopes and how they work through functions, the scoop chain, and being able to identify different levels of scope in JavaScript. Yeah, that's a thing. That's a thing we're going to be talking about. Okay, so, I have no, there it is. Not no power, but definitely need more power. More power! All right. Any fans of Home Improvement? Show Home Improvement? Yeah, he was always about getting things with more power. All right. Cool. Who has ever read a Choose Your Own Adventure book? All right. We got any fans of the Choose Your Own Adventure books? Who doesn't know what a Choose Your Own Adventure book is? Never heard of them. All right. Well, when I was a child, there were these books. Yes, they were in Latin. There were these books. They're called Choose Your Own Adventure books, and the idea is that you start at the beginning, and all the narrative is second person. You walk through a door. You blah blah blah. You. And what happens is that it describes a scenario that you are in. And they get to a point where they're like, okay, the alien reaches out his hand. To take the alien's hand in friendship, go to page 161. To reach for your blaster, go to page 183. Right? And you'd obviously go to page 183. And then they would be a different scenario. So there's a story. But if you tried to read a Choose Your Own Adventure book in order, it would make no sense. It would make less sense than the first time you watched Pulp Fiction. All right? It would. Because even then, at least that's one story all out of order, right? This is a bunch of different twists and turns the story could take. So code is like that. Doesn't go in a linear progression, right? So let's Python tutor, JavaScript.html. Does anyone know what this is? Python tutor? Anyone? Okay, this is fantastic. You know what's up. This is a really fantastic tool for kind of seeing your code, stepping through it step by step. Let's do something. There's this one programming problem that comes up every now and then. It's sort of how can you do this? And it's called FizzBuzz. So we're going to implement FizzBuzz. And this is basically a game you're playing if you have a group of friends and you are super bored. Like you are trapped in the middle of a snowy wasteland and you're waiting for help. Like this is when you pull out FizzBuzz. But the idea would be that we would go saying numbers like 1, 2, 3, 4, 5, 6. Now, if the number was a multiple of 3, you wouldn't say, it wouldn't say 3, you would say fizz. And if it's a multiple of 5, you say buzz. Right? So it would go 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz. And if it's a multiple of 3 and 5, so basically if it's a multiple of 15, you would say FizzBuzz. Oh, you guys are way ahead of me here. All right. So, okay, yeah, you guys did Loopy Lighthouse. That's right. Same thing, only less branded. Clearly, this is sort of the no-name version of that. All right, so what we want to do is we want to go from 1 to 100. So what's an easy way of doing like something 100 times?
Writing it out 100 times.
Writing it out 100 times. You're not wrong. Copy paste. Control C, Control V. I appreciate that. So a loop. So what kind of loop? So I just write a loop. 4. All right. So what's that for? What do I write? Var I equals. And we're actually going to start from 1. And we're going to go I is less than or equal to 100. And then I plus plus. All right. Which may also be written as I plus equals 1, or I equals I plus 1. All right, so what I'm going to do here is console.log I guess. Or what I can do here is, let's set up some, I guess we have to set up some if statements, right? If I, how do I check to see if it's a multiple of something? The modulo. So if I mod 3 equals 0, that means that this is a multiple of 3. Else, we'll do something else here. And then we're going to check if I mod 5 equals 0. Console.log fizzbuzz. Else console.log fizz. And then here again, if I mod 5 equals 0, console.log buzz. Else console.log I. All right. It's a terrible joke. I'm not going to apologize for it. Know that I probably should. I'm not going to. Okay, so here's what we're going to do. Now, if we were just kind of running this in a REPL, if I just went back to this, open up this, open up one of these fellers, printed it, then we would get all of this stuff, right? It works, which is what we expected. 58, 59, fizzbuzz, yeah, that's what we wanted. But that doesn't really tell how this is going to move. So here's what we're going to do, is that I'm going to start the visualize execution here. And we're going to figure out where this, steps 1 of 502. And for every step here, every step, you're going to tell me where the cursor should go. All right? So here it obviously starts at line 2. Okay? Where does it go next? Line 2 again. Sorry, that was, okay, because it checked to see if it was, I'm sorry, that was, okay. All right, try it again. Line 3. Cool. What is I? Is 1 mod 3. What's 1 mod 3? It's 1, right? 1 divided by 3, the remainder is 1. Okay, so where is this going to go? Where's my red arrow going to go? 9. Well, 10, yes. But you had the right idea. I'm giving him the point. There's no points. Points don't mean anything. You get 2 points. All right. And the rest of the day, if someone disagrees with you, you can be like, you're going to argue with a dude with 2 points? What's with you? All right, so is 1, what's 1 mod 5? 1 again. Is 1 equal to 0? Not even triple equal to 0. All right, so I'm going to, where am I going to go? Lucky 13. Cool, cool, cool. Then where are we going to go? Sorry, I stepped forward a little bit. Back to 2. Then where are we going to go? Ah, you're not sure if it's going to be 2 again, are you? Me neither. Let's find out. Yes, it's 2 again. I think because the first thing it does is it increments I, and then it does the comparison, which is technically code, right? Yeah. Okay, then to 3. 2 mod 3. What's 2 mod 3? 2. Is 2 equal to 0? No. So where does this go? 10. Yeah. 2 mod 5. What's that? 2. Is it equal to 0? Nope. So console log I. All right. Back up to 2. Where's it going next? 2. Ah, well played. All right. So where are we going next? 3. What's 3 mod 3? 0. Is 0 equal to 0? Yes, it is. It's even double equal to 0. All right. So that means where are we going next? 4. What's 3 mod 5? Is 3 equal to 0? Nope. So it's going to be 7. And then what are we going to see on the console? Fizz. Cool, cool, cool. And we got 4. Where's 4 going? What console log is 4 eventually going to end up at? What line? 13, you say? Oh, that seemed to have been it. 13. So we have 4. All right, that brings us to 5. What's 5 mod 3? Is 2 equal to 0? No. So where are we going? Line 10. What's 5 mod 5? 0. Is 0 equal to 0? Yes, it is. And so it's going to say buzz. All right. Now we're going to zoom through this. All right. 6. What's that going to be? Like, well, no, I mean like what is, oh yeah, it's going to be, so what's it going to say? Like what's it going to put on the thing? Fizz, right? All right, 7. Just 7, right? 8. 8. Doing good. 9. Fizz. 10. Buzz. 11. Just 11. 12. Fizz. 13. 13. 14. And 15 is buzz. Let's get this thing moving. 19 fizz, buzz, fizz. 22, 23, fizz, buzz. 26, fizz. 28, 29, fizz buzz. Yes.
For line 2 and 4, is there a reason why you decided to do 2 if statements instead of like just doing I and 3 and?
Okay, so say this one more time.
So is there a reason why you did 2 if statements instead of just doing 2 and signs in the same bracket?
Yes.
Yes.
Why did I do 2 if statements? The question is. And the answer is reasons. So the thing is that I basically do something based on it being 3 and something based on it being 5. And I actually have like kind of a square grid, right? Is it a multiple of 5? Yes, no. Is it a multiple of 3? Yes, no. And I have different things that I do based on that. For the yes, it's a fizz buzz. For the no, it's a fizz. For this is a fizz. Now what I could have done,
Yeah.
what could have been the way I did this, is I could have, let's go back here. I could have var words. We could have some words. And I could say if I mod 3 equals 0, words plus equals fizz. And I could also say if I mod 5 equals 0, words plus equals buzz. And then at the end here, I could have said if words is nothing, console.log I else console.log words. That would have been a way to keep from doing nested checks. But since I was going to have to do 2 checks anyway, this is kind of the most performant and least readable version of this. Right?
Okay. I was just wondering because it's very similar to the Loopy license assignment.
Is it similar to that? I guess it is.
It's like almost exact.
Yeah.
So like for when I did that, that was what I did was for the first if statement is I just did 3 and 5 and then continued to the other numbers. Because there are
Yeah.
So she wrote like 3 if statements.
Right.
But
Did your guys look like this?
no,
What
like
did-
I didn't write extra if statements for that. Like I combined those 2 values into like one. What's that?
yeah.
So it was if I one equals 3 equals 0 and
Right. Okay, so what you did was you checked to see if it's equal to 15, and then you checked if it was mod of 15, and then you checked to see if it was mod of 3, and then checked mod of 5.
Yeah.
Right. Well, I figured.
and then else if for just checking 3.
Yeah, you did else for 3. Yeah, I just wanted to do as few linear checks as possible, right? Because if you check for 15 and then you check for 3, well, technically, like, you sort of check for, like, is it a multiple of 3 under this particular situation? No. Was it, like, generally a multiple of 3? Yes. So I figured I would, like, since all of my things add up, I would just do it this way, because reasons.
I'm wondering, 'cause it's 2 if statements that I combined into one. I'm wondering if there's a reason why you made
There's a benefit.
There is technically a benefit, which is that each thing that you check is a performance cost, right? So even though it is 2 statements within, like that's the cost of 2 statements. So I just wanted to make as few linear statements as possible, and that's why I did this. Also, if I were so inclined, and guess what, I am, I could say console.log words or I. And that is a use of JavaScript's super goofy truthiness. Yeah. Right. Yeah, you're going to see a lot of that coming up. Right? But this is the same thing. Now let's hold on. Give me a second. I can use a ternary operator. That is also the case. I'm going to put this in my notes. Code and scopes. Code flow. Loopy. Not Loopy Lighthouse. FizzBuzz. Nested ifs. And then yeah. And the ternary would be words, else I. Or words bang equals papa. That'd be another way to do that. If I were ternarily inclined. I think I'm going to keep, not that code. I'm going to keep this code. You know, sort of. This isn't necessarily how I would code things in my own stuff, but, you know, same shit, different day. All right. FizzBuzz. Parallel ifs. Okay, so iMod 3 is 0, iMod 5 is 0. Calgary, I hope you got benefit out of that particular conversation, because I know you can only hear parts of it. But I hope that what I did relay back is helpful. Let me know if it wasn't. So yeah. So there is kind of like, but we've kind of explored this, like, you know, you go into nested structures, they redirect you to things. There used to be, back in the day with some languages, they have a thing called go to, and you would say go to a certain line, right? And there was a there was a thing, I think it was called structured programming, where someone's like, these things are terrible. So they built ifs and for loops, but the for loops and the while loops and the loops and the ifs and the things, they're just doing the same thing, right? An if statement is just something that redirects you to a different line based on a certain code, based on a certain condition. A while loop is just an if statement that takes you back up to the top when it's done to check to see if its condition still holds true. That's all, right? And then the for loop is just an expansion on the while loop. Does that make sense? Right? So that's kind of doing the same thing. We're just kind of moving the cursor around as we go. Okay. I want to introduce you to something. The next thing I want to introduce you to a bit is the stack. The stack. So the idea with the stack here is that if I say, let's say I make a function here called greet person name, and I might say console.log hi name, right? I could also make this a plus just to make that clear, right? And then down here I might say Ardelia. That's right, you're famous now. All right. Okay, so I want to show you what this looks like on the side here. So right now we're in what's called the global frame. Code's just sort of running. We did everything there on the global frame. It was just this little blue block never changed, right? So what I'm going to do is I'm going to take a step forward, and it's going to be invoking this function. It's going to be running this function, calling this function, applying this function. There's a lot of words for what it's going to be doing, but it's basically just going to be doing this thing, right? So what's going to happen is it's going to have to open up a new thing on the stack, right? So now you see something called greet person, and it has its own variable name, Ardelia. Now it's called a stack. If you have a stack of plates and you just let's just say you have a yellow plate and a blue plate and a green plate and a red plate, and you get them all out of the dishwasher, and you kind of put them, you just kind of grab them at random, but you put down the green plate and the red plate and the blue plate and the yellow plate, right? Which is going to be, if you have breakfast the next morning, which plate are you going to have the breakfast on? The yellow plate, right? Because at the top of the stack. So when we would say that you were pushing the green plate and the blue plate and the red plate and the yellow plate, is that the order I said it in? Pretend that's the order I said it in. You were pushing them onto the stack, and then take one off is to pop it off the stack. There's also a thing called a queue, which is like, if you join a line, you push yourself into the line, and if you get to the front of the line, and then go get your donuts. This became about donuts again. A surprising amount of my analogies are about donuts. It's good donuts in this town. Okay, so then you kind of get your donuts, and you're like, cool, then you've been popped off the queue. Push, pop. Okay, so this is a common thing. There's another structure that has a push and pop called the heap, but that's another story entirely. Another story entirely. So what's happened here is that we have popped one onto the stack. We have greeted this person. Like we're into the greeting of this person, and what's going to happen is that we're going to go forward. We're going to console log hi name, and then it says return value undefined. We're done with this function. And so what happens when we're done with this function is, can anyone guess what happens? It gets popped. All right, it gets popped off the stack. Not like gets popped. It gets popped off the stack. Well, a little bit of that, if that helps. If that helps you visualize it, gets kind of smacked off the stack. So now it's, yeah, it's. So let's do this. Do a bit of an example here. Let's grab this. Let's see. So I guess we'll call those the go-tos. Go-tos. Fizz, buzz, and if, parallel ifs. And then we'll do a stack simple stack. All right, let's do a more complicated one. I'm going to do something recursive. You don't have to know about the recursive part. If you happen to know about recursiveness, then you already know about it. If not, don't worry about that part. But what we're going to be doing is we're just going to be calling a function from within another function. That's the part we're going to care about today. So has anyone ever heard of the factorial function? Good. Good. All right. Man, I got another donut analogy. I was going to be like, what's my go-to analogy for this? Oh, yeah, donuts again. So let's say I have a donut blog. And I'm not saying I have a donut blog. I mean, so let's say that I have a donut blog and I have these 4 donuts. And I'm trying to figure out what the best order is to eat these 4 donuts. Right? So I got like an Earl Grey, and I got like a salted caramel, and I got like a citrus glazed, and I got like there's a PB&J one at Lucky's that is, it is an experience. It's a wonderful experience, right? So what happens is I have these 4 donuts, and I'm trying to figure out what the best order is to eat them in, right? And I could be like, well, do I go to the more like salty to the sweet ones? Like, what's the right order? And it occurs to me there's no way to know except to run every single combination, right? So I start with these 4 donuts, and I have them one morning, and I write about my findings in my blog, right? And then I switch the last 2 donuts, right? And so I get all 4 donuts again, switch the last 2, eat them in that order, write about that. And then as I go, I just make sure I have every possible combination of every donut. Well, how many days will it take me to finish this series? 4 factorial. So what that means is basically, well, I'm going to spend, if I have an Earl Grey here, and then the salted caramel, there's 2 ways the other ones can go. So that's 2 days. So I'm going to then take the, what is it, citrus glazed? Yeah. I'm going to take the citrus glazed, and then I have to go have donuts after this. I'm going to have, so Earl Grey, citrus glazed, and then there's like 2 options for the other one. So that's 2 days of that. And then Earl Grey, PBJ, which does not sound like the right combination, I'm going to guess, but science! So experimentation of that is Earl Grey, PBJ, citrus glazed, salted caramel, then citrus glazed. And then I switch those 2, right? So that's 6 days of Earl Grey first, right? And I'm going to do that with all 4 of them. So it's going to be 24 days total, which just sounds awful, right? So the idea here is that the notation is an exclamation mark. It's not just a surprised 4. So it's 4 times 3 times 2 times 1. And who cares about the 1? I kind of care about the 1, right? But that's just it. That's 4 factorial. So if I were to write a factorial function that was just an iterative function, it would be pretty simple. Function factorial iterative. I like long names, long descriptive names of things, by the way. Number, num. You all know what num is. And I'm going to say, var output, var kind of running product equals 1. For var I equals 1, I is less than or equal to num. Also, by the way, I'm just going to say if num, actually, no, it's fine. Num I plus plus running product times I. I can make this 2. That's fine. Oh, running product times equals I. Return running product. Console.log factorial iterative 4. So let's see this bad boy go. Unexpected token, phi equals 2. Oh, fair enough. I had a typo. Unexpected token. I'm an over-caffeinated dum-dum. There we go. That won't help them. Okay. I'm sure by now they have my IP address on file. So running product is 1. All right. Times 2 means running product is 2. Times 3, running product is 6. times 4 running product is 24 times 5. We don't do 5. Return running product, it is 24. We have our correct number of donut days, right? Okay, so this was iterative. You know, here's that factorial iterative. There's what it's going to return. It has a return value. Return values are all the thing, right? Yeah. In this case, we don't really want it to do something. We want it to return. We'll talk about that in a moment. But it has a return value of 24. That's what we wanted. Cool, cool, cool. Print us 24. All right. Now I'm going to make this. And the only difference here, the real difference, the only thing that matters, is that we're going to call this from within itself. And that's going to let us see a big old stack form up. The main point here is just seeing a big old stack. All right? Don't feel that you have to remember what recursive means. That's for another day. So what I'm going to do here is I'm going to have my base case. If num is less than 2, return 1. Otherwise, we're going to return num. See, I should explain the recursive case just for a moment, which is, if 4 factorial is 4 times 3 times 2 times 1, what is 3 factorial? Well, then it would appear that another way we could write 4 factorial is we could say that 4 factorial is 4 times 3 factorial. Oh, well, so we're going to do that. We're going to say that we're going to return num times factorial recursive num minus 1. That's right. Heard this little trickle chorus of num minus 1, num minus 1. All right. And then I have to remember to go back to this and actually ask for factorial recursive here. Ha. Okay. Now what I want you to watch is this thing, because we're about to get a stack. It's about to get stacked. So factorial recursive of 4. Is 4 less than 2? No, it is not. So we're going to return 4 times factorial recursive on 3. All right. Which means we have to find factorial recursive of 3, right? So now we add another one to our stack. So let's solve factorial recursive of 3, and then we can do the rest of this, right? Factorial recursive of 3. Is 3 less than 2? No, it is not. So we're going to have to return 3 times factorial recursive of 2. Yeah, we are. One more time. Now you see this stack growing, right? Okay. Factorial recursive of 2. Is 2 less than 2? Oh, almost. Almost. But in fact, we're going to return 2 times factorial recursive of 1. Is 1 less than 2? Okay. Now we're going to start seeing this fall apart. All right, let's do that. What's this going to return? Cool. There it is, return value 1. So what is factorial 2 going to return? 2 times, which is dos. El grande dos. El dos grande? Where does the adjective go there? It doesn't matter. That's the story for another day. All right, so factorial recursive of 3 is 3 times factorial recursive of 2. So that means that factorial recursive of 3 is going to return 6. I made it go before you guys got a chance to answer. But now we have factorial recursive of 4 is 4 times factorial recursive of 3. So it's going to be 24. 4 times 6. And then the stack is done. So let's kind of run through that again. We kind of saw the stack build up. Now, again, this is not one of those situations where you can slip a plate out from the under the other ones. If you want to get something, you have to pop your way down to it. Okay? And that is, that's push and pop right there. That is what a stack looks like. You can kind of see that each stack had its own sort of values. All right. Scopes. Scopes. Okay. So this is... Oh, this is the home of all sorts of JavaScript gotchas. I'm not going to lie. Is what variables are available where? All right. Okay. So let's start with this. Tell me I pronounced that right. Huh? K-A-N. Ah. So close. Okay. If I said here, what do we expect to happen? Hello, Conwall. So what happens is, let's just run this real quick. So the name is a variable, as you can see, on the global scope. It exists out there on the global scope. These frames are also sort of like they hold variables. They can hold variables, right? And in this case, when greetPerson goes in here, it's okay for it to say name because it's out there on kind of an outer scope, right? So it's easy to say, hello name. If we wanted to, we could reassign that from here. Name equals Eric, right? So if we did that, name Conwall, greetPerson. Here we are, name Eric. Hello, Eric, right? And you can see on the global frame, this is still Eric. In fact, let's do a console log of name here. So because this is where it's written, I have the ability from inside this function to read and write an outside variable. So what would happen if I said var name equals Eric here? It becomes a local variable. It becomes local to this function. Let's take a look to see how that shapes out. So we're going to go in here. greetPerson. We start a stack, and now the stack has a variable called name. Okay. And what's that name going to be? Eric. And so this is going to say console log, hello, Eric. Now here's the question. When I return to this, when I get down to line 9, what is it going to say? Conwall, right, because now what happens is with the function scope is that it invokes the function, sets up all the variables, and then it kind of just like puts a garbage bag around it and throws it all away. All that stuff that was in there. I feel like in this case I need a big old, like it's not exactly true, like that's a helpful way of thinking about it. It's not going to be exactly true, and we'll show that in a second. But for the most part, you can think of like when you invoke a function, when you put it on the stack, you have all these variables, and then like you make these variables, you do these things, and then you throw a garbage bag around it, and then just throw it out. We're not throwing you out, Eric. It's fine. All right. Right? But now the fact that I said var, when it got to here, this name variable was like, okay, do I have a name in my local scope? Do I have a variable called name in my local scope? Well, yes, I do. Okay. Well, I'm going to use that one. If it didn't have it, it would start looking further out. It would look further and further out. So, no, that's not what I wanted. Edit scope. Okay. So this is a simple example of let me, I said local scope, and then what else did I say? global scope. All right. Now, what would happen if I made a function here called innergreeter? And I said name equals Sylvia. Okay. So we're going to get down here. Visualize execution. Of course, nothing's going to happen because I didn't call it. I realized there was a skeptical look, I think, on Michelle's face. And I was like, I wonder if she sees something I don't see. So, okay, so what I'm going to do is I'm going to go here. Greet person. Our name is Eric. Okay, cool. I have an inner greeter. Name is Sylvia. And you see how it has this variable that says parent name is Eric, right? So what happens when I say name is Sylvia? So this one, so who thinks this one's going to change to Sylvia? Raise your hands if this one right here for inner greeter. Who thinks this is going to change to Sylvia? Who thinks it's not? Who thinks it's not going to change? Now, I want to point out, a lot of you didn't have your hands up. This isn't about being right or wrong. This is about forming an instinct, seeing what happens, updating your instinct. That's how you get better. So let's try this again. There's only two options. Either it's going to change or it ain't, right? I'm talking about inner greeters. Now, the parent name there, who thinks that's going to change to Sylvia? All right. Who thinks it's not going to change? Okay. The name on greet person, who thinks that's going to change to Sylvia? All right. Who thinks it's not going to change? All right. Conwall up there, who thinks that's going to change to Sylvia? Who thinks that's not going to change? All right. We're going to find out. Now, parent name here and name were both pointing to the same variable. They were both. It got to name and it was like, well, I don't have a local variable called name. Where's my closest variable? And it went one stack out here to var name is Eric, right? And then it changed that one to Sylvia, has read-write access, so it can change it to Sylvia. And then it's going to say, hello, Sylvia. But it stopped here. It stopped here. And the reason it stopped here, instead of going to Conwall, is because like it was able to find something there and then didn't feel the need to search any further. It wasn't for changing things up and down the pike. Now, this isn't just about, I'm going to be very clear, this isn't just about the scope. So I'm gonna so inner function, because, or it isn't just about the stack. Did I say scope? It isn't just about the stack. It's also the fact that it's actually written in here. That's why it has things. So if I took this out, and this no longer, this function inner greeter, that's not what I wanted, even a little bit. And this function inner greeter lived out here. In fact, let's put it up above. Then it would overwrite. So let's visualize the execution. We had Conwell, greet person. Our name is Eric. Inner greeter now no longer has that parent name. It's actually about where it's written, not just the fact that it's on the stack. I would recommend playing back and forth with these ones, seeing them change, developing an instinct for it yourself. It's not just gonna, if it doesn't make sense now, play with it.
What if you move the console log above the variable name?
If I move the console log above the variable name, see, this is an example of what we can play with. How about I copy it like that? Sure. Let's do this. Okay. You have Eric, inner greeter, console.log, hello, name, and now it's going to see. So which one's it going to change? Who votes it's going to change Eric? Who thinks it's going to change Conwall? Jeremy, what do you think?
I'm not sure. I'll need an experiment.
Jeremy's not sure he'll need an experiment, which is why I think you're fantastic. All right. Hello, Conwall. Name is Sylvia. Hello, Sylvia. And the reason is because it's of where it's written, not just the stack. I know. Hello, Sylvia. All right. Well, it's going to look at the kind of the globals and locals where it exists first, if that makes sense. And another important part about this, so I'm going to say inner function, kind of parallel functions, is this. The other thing I want you to notice is if I say, so function make variable var name equals, who else we got? Got two Benjamins, two birds with one stone. All right. Okay. Take a look at this code. What do you think? Who has a theory for what's going to happen? Not Spencer. Sorry, man. I know. Good. All right. What was that? So we're going to have an error. So I hear undefined. Someone thinks name is going to be undefined. What? All right. Matt says error. It's okay. So I hear reference errors. All right. Let's find out. I'm actually, like, part of me is now like, do I know exactly what it'll do? Am I totally sure? We're going to find out. So make variable, indeed, there is a name variable, right? We're totally cool with that. All right. Make variable is now done. We're going to throw it away. Uh-oh. Uh-oh. Reference error. Name is not defined. So it's not just the value undefined. It is... I don't know what you're talking about, because that all happened within the scope, within the sort of like little bubble of that function. And I cannot, from the outside of the function, kind of get into that function and change stuff that happens in it. Right? So, yeah. Not. So.
There's absolutely no way to make global variables in JavaScript. Like they just took out that hedonistic practice.
Making global variables, sure, there's lots of ways to make global variables.
Sorry, in like a function, within a scope like a function.
I'm going to go ahead and say don't.
Yeah.
But there is a way, but
Sometimes
also
like
don't.
burn.
Okay, yeah, someone liked to watch the world burn. All right, getting var from outside. Yes, there is. I don't want to do it, Spencer. You can't make me.
Dark arts by educating us.
So, I mean, I hate to be a Trelawney here, but I'm not gonna. All right. So what I'm going to say is that is like specific. Each environment has its own way of adding global variables. If you really had to, which you don't. Well, you do kind of in browsers, and we'll get to that. But global variables, by the way, are a little like if you have a bunch of roommates and you have like a common area. It's like leaving your shit in the common area. Yeah, sometimes there is like or like a panini press or something like that. That might be nice to leave out. Which is basically how stuff works in browsers. I can't, you won't. All right, so there's one thing I do want to get to, by the way, and this isn't scope like real scope. This is scope like conceptual. Like this isn't enforceable in ES5. It isn't enforcement in ES6. which is this. Let me say for a moment that I'm doing this particular I is less than 6. Why not? I plus plus. And I'm going to say var square equals I times I. Console.log square. All right. And down here I'm going to say, just so I have some code here, console.log hi. So I'm just going to go from 0 through close. So square I, so that you can see that there's variables I and square, right? And you saw that I have var I and var square there, right? So we're going to go through 0, 1, 4, 9, 16, 25. Okay, we're done. So now we've gotten to console.log hi. Now, do we really care about I anymore? What was the point of I? Yeah, it was a counter, right? And what was the point of square? Well, the point of square is that we're just kind of making something that we only care about in the course of this loop, right? But now we have 6 and 25 kind of just polluting up our space, which is something that gets cleaned up in ES6, which is a talk for another day. Ugh. So the fact is that we still have variables that really only matter within the context of this loop of 1 through 4 here, that they're still kind of out, just chilling out, just being there, And we can still access them, but they don't mean anything. They kind of only mean something within that. And in fact, square, the meaning of square, what's up, Kevin? Gets rewritten every time we kind of go to the top here. So that's it. You could wrap it in iffy. That is true. That is an immediately invoked function expression and a story for another day. So you could make a little function wrapper here if you wanted to, but also, I like the cut of your jib. We could write a for function. We could write a for function that would do that within a function if we really wanted to. If we were which may, you know what? I'm gonna leave that as an exercise for the reader. I'm gonna leave you. If you want to do that, that's the thing you could do. I will leave it as something where you're for fn, you have to have some sort of function that that maybe gives you an initial value. You just put an initial value like 0, and you put in how it's supposed to increment, which is I function I return I plus 1, and then what you do with it, what is it you do? You could do this, and then it would be you could make any variable in here and it'd be safe. And again, I leave this as an exercise for the reader. If you're into that sort of thing, we can talk about that. We can make that available to you. And if you do get that, and if you do finish the exercise, what you get is nothing. I'm not doing anything for you. All right. What you get is to leave me alone in the queue for a bit. All right. So that is a bit of code and scope. You're going to be moving things around, and it's going to seem a little arbitrary what the rules of scope are. Obviously, I can rattle through them because I've given this breakout 5 times, right? But I want you to get used to just kind of experimenting with where variables should be. Use Python Tutor so you can see what variables are still available, still hanging out, still just loitering around. All right? Cool. Oh, and the main thing is that I'm showing you some stuff. I'm giving you some sort of frame of reference. But my lectures and that sort of thing, this is kind of the first we're just talking about a JavaScript topic. I want to make very clear that while the lectures are important to attend and listen to and understand, they may not make sense the first time. So if you are feeling in this room, I'm not saying anyone is, I'm just saying that if you were feeling I didn't get all the things or I couldn't reconstruct all those exercises, you can watch the video later. you can play with the examples, and you can sort of run them themselves. And a lot of this stuff is not going to make sense at the hearing. You have to actually like play with it a few times. And again, what I suggest is that you set up some code, you think about what you think it should do, you see what it actually does, and you update your instinct. All right? All right. Y'all have fun. Talk to you later.